Extremely super duper important it is to use Kelvin. Please, 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 please use Kelvin when you do these problems. Okay, I'll repeat that over and over again, so don't worry. Okay, so last time we looked at all that, we talked about gas laws. Now we're looking at how to do problems with the gas laws. So I'm going to show you a few examples, but let's go over these parts first. Some questions will have all three variables, so it'll mention the pressure, temperature, and the volume. Or sometimes it will only mention two of them. If a variable isn't there, for instance, if it's talking about the pressure and temperature and says nothing about the volume, ignore it. If it says it's held constant, so it talks about the pressure changing and the temperature changing, but says the volume is held constant, you can also leave that out of the equation, leave the volume out. The really super duper important part here is that you write out your variables, right? I know some of us think, oh no, I could do it in my head, blah, 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 I got this. You're gonna mess it up if you don't write them out. So save yourself the headache and just write them out when you see them in the question, the way I'm gonna show you up next. Okay, then once you have all those variables written out, you can just plug it into the equation and it's as easy as that. Okay, so let's see.
Example 1. So before I get into this, I just want to point out that I have P1, V1, T1, P2, V2, T2. What do those little 1s and 2s mean? So P1, V1, T1, that is what I'm starting with. P2, V2, T2 are the values we're going to see after some sort of change has been made on the gas. And we will see what that means in a moment when we do this question. Okay, so now we're going to go piece by piece and pick out the pieces of information that are given to us and what we're trying to find. Okay, gas occupies 1 liter. Ding, 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 there we go. First piece of information, 1 liter. And liter is a unit for volume, so it's going to go in my V1 box there. Okay. Next up, standard temperature. Standard temperature. Okay, that is a piece of information. What does that piece of information mean? Well, let's take a look at our handy dandy reference table. Okay, 273 Kelvin, 0 degrees Celsius. 273 Kelvin, 0 degrees Celsius. Okay, so it's giving me 2 numbers for that. So I'm just going to put that on the side for a second. So it's either 273 Kelvin or 0 degrees Celsius. We'll talk about that in a second. All right, what is the volume? All right, anytime a question says what is the, that's going to be what you're looking for. So that's going to be your X. Okay, at 330 degrees Celsius. Okay, so that's my second temperature. All right, so should we use Kelvin or should we give Celsius? The question gives it to us in Celsius, but you always use Kelvin. Always, 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 always use Kelvin for gas law problems. So, gives it to us in Celsius. How do we convert to Kelvin? Let's see. 330 degrees Celsius. All you have to do is add 273. Any value of Celsius, add 273, and that will give you Kelvin. Okay, so let's get this abomination out of here, right? No Celsius. We're going to put 603 Kelvin there. I'm just going to clear it up over here, only using Kelvin. Okay, so let's see our combined gas law. If you turn to the back of your reference table, there's the combined gas law, and it gives you P1, V1, T1 over P2, V2, T2. Okay. And if we look at this equation, if we look at where we wrote out our variables, there's no pressure, right? It doesn't mention it in the question. We don't care about it. We can totally forget it. So let's cross it off the table and let's cross it out of our equation also. Okay. So now is the fun part. You just plug it in there. So I have my V1 up top here. That's going to be this 1 liter. my V2, that's going to go up there. X, that's what we're solving for. And T1 is going to be 273. And my T2 is going to be 603. Kelvin. Okay, so now at this point, you just solve for X. Okay, so that will give me 603 times 1 is equal to 273x. Divide both sides by 273. And I'm going to go over here. X equals, so the calculator will give you 2.218, blah, blah, blah. Just round it to 2.2. 2.2 what? Kittens? No. Right? So we're looking for volume here. The volume is given to us in liters, so this will be 2.2 liters. Okay, so we're going to do this one the same way. We are going to list out the variables as we read through the question. Okay, let's see. Example 2. If a gas in a closed container is pressurized from 15 atm to 16 atm, oh, got some information there. Okay. 15 atm to 16 atm. All right. ATM, does it want me to go to the bank or something? Haha, no. All right, so let's take a look back at our reference table. Okay, ATM, that means atmospheres, and those are a unit of pressure. Okay, so I know that I can put those in the pressure spots. All right, so 15 atm, 16 atm. How am I supposed to know which one to put in P1 and P2? Well, from 15 atm to 16 atm, so if I'm going from my house to school, I'm starting, right, 15 atm, that's my starting point. 16 is going to be my ending point. Okay. And its original temperature, so that's what I'm starting with. Original temperature was 200 Kelvin. I could put that down there. And it says, what is the final temperature of the gas? So that is going to be my X. All right. And in this question, it said absolutely nothing about volume. Forget about it. All right. And we'll do our combined gas law equation again. P1, V1, T1, P2, V2, T2. All right, and what did we say we don't care about? Volume. All right, get that out of there. Okay, so P1. P1 is 15 atmospheres. P2 is going to be 16 atmospheres. Okay, temperature 1 is going to be 200 Kelvin. And my X is going to go down here for T2. All right, so favorite part, I just solve for X. That will give me X equals 213, and again, another rounding situation. It's going to give you 213.33333333. Let's just leave it at 3. 213.3. 213.3 what? Well, we are solving for, it's asking us for temperature, right? So, Celsius, right? No. Always put Kelvin. 213 degrees Kelvin. Okay, and that is our answer for this one. All right, next up. Okay, example number